Hello guys, welcome to my YouTube channel Learn to Code with Noob. So this is the Typescript Series episode 8 and we are going to learn some other advanced concepts of generics. So I personally feel like generics are a very powerful tool of any object oriented language. So we have used generics in Java, in C Sharp, and if we are using an object oriented programming, I would not say object oriented programming in TypeScript, but generics are still there in TypeScript, which I personally feel it's very important concept, and it allows us to make very good reusable functional components. So today we are going to discuss some important concepts such as generic classes, generic constraints, type parameters in generic constraints, class types in generics, and index signature. Alright, so moving forward with our generics concepts. So the next concept is generic classes. So as same as interfaces, you can actually define generic classes. They work in a pretty same way. Uh, so I will give you a quick example. So for example, you want to describe a class which is used for basically reading the API response, right? So the API response can have different sort of data. So basically, different endpoints can have different sort of data. So you so with the power of generics, you can basically write a generic API response class, for example, and you you can define the generic type T with an angle bracket, right? And then you can have a payload which will be of type T, right? So now what this will allow us to do is, so for example, if the server is sending us a number type of response, this is a very like basic example. So you can over here you can define the type, and the server can actually write like on their end. They can write like, okay, I want to send 1 or 2, whatever, right? And the same thing. So if you want to like read this value too, right? So if you want to say let payload value, right? So payload value can also be a number, right? And you are sure that this will be a number always. Same thing obviously will be if the payload data is a string, right? Then you can have the same thing. Instead of number, a string, and again you can read the same value, right? Value to string response. Oops. String response dot payload. Now your response can also be an object type. So let me define simple object like API response or API payload, right? And that type contains, let's say, an ID and a value, right? So now if I do this payload response, right? Payload response, new generic pay response, and I can have pi payload type in there. And now if you want to read this value, right, you can do payload, and then it will automatically will show you, okay, this payload has an ID and a value. So the power of generics is like basically you are using one class only, right? And it can be used in many different purposes, but you are basically reusing the same class but for different type of data. So that's the here comes the power of generics. All right, so moving on to my next topic in generics is generics constraints. So remember we actually wrote a function which was function same, right? And we were defining uh, a generic type t, right? And it takes an argument of type t and basically return the same argument, right? But if in this function we were trying to access like a length property, TypeScript complains about it, and the reason is because if you go into my last video, which is TypeScript episode 7, uh, there I clearly mentioned the reason of this is TypeScript in the parameters. If you define it as a generic parameter, it's like the function has to be valid for any and all types, right? So if for example this parameter is of type any, let's say, so it doesn't mean that it will have a length property, right? So to actually make this thing work, what we did was we basically said, okay, just have this type as an array, right? And if you will have this type as an array, then arg.length will work. So but what if you want to have a function in which you want to make sure that, okay, whatever the types which we are passing, they are constrained to a length property, like it should have a length property. Whatever the types we are passing, it should have a length property. So so how can we do that? So in order to do that, we can have a type which is, for example, a length constraint, you can say, right? And this length, in this length constraint, we will basically have a property as length and number, right? And then what you will do is over here in the same, you can just say t extends length constraint. So this is one of the example of generic constraints in which you are making sure whatever the type which is passed in the input of a function, it should have a length property. Now if I will do like same of 1, right, it will not work because 1 doesn't have a length property. And if I'll do this string thing, it will work, right? And if I'll do like true, right, it doesn't work. And even if I do an object, right, which has a length property, this will work. So here we are basically making sure that the function is constrained to the length property. So another one of the powerful feature of generics in TypeScript. So with this, actually you can build very like robust functionalities, or you can build robust functions which are reusable, and they are basically constrained to whatever the constraint you want to apply on those parameters. We will have some more examples following this generic constraints in the video, in this video. All right, so moving on to my next topic, which is type parameters in generic constraints. So what does that actually mean? In the previous part, I explained that what are generic constraints. In like, you can actually apply generic constraints inside like functions, right? Inside a function. So but you can also define a generic constraint by a type, like in the type parameters. So let me give you an example. So for example, if you want to have like a get method, right? So suppose this get method is basically a method in the map, so a hash map, I would say. So in that, what I want is I will pass uh, an object which has a key value pair, so which is t, right, as of generic type t, and I will also pass the value, a key value which is of type k, right? And in that, I just in the parameters, I will just define that there is a map object, right? Map object of type t, and there is a key value of type k, right? So if I do that, I will just basically return that, hey, whatever my map object is, and here is that key value, right? And whatever my map object is, here is that key value, and it will return that key value. Okay, so now here comes the error. So it basically says k cannot be used to index of type t. So what this basically means is that we cannot use a type k, right, in the which is of type t, right? And a key type k, it means a key cannot be used to index type t, which is correct, right? Because technically we are not making sure that this map object, whatever the key we are specifying, it actually matches the type or not. So in order to do that, what we can do is in the k, which we can say that it will extend key of, right, type t. So what this is telling TypeScript is that whatever the key value which I will specify, right, it will be it will always be present in this type t, right? So whatever the k value I am specifying. So let us take an example. So I will specify a map object. It has a key value pair, say a1 b2 c3, right? So now if I want to call get method, specify map object, and if I'll specify a, this will work. But if I'll specify it, let's say d, right? So d is not a key which is contained in this object, so that's why it will complain. So here is a perfect use of type parameters in generic constraints. Okay, All right, so moving on to our other use of generics, which is using class types in generics. So this is also mostly used in object oriented programming languages, where we have like a factory pattern or something like that, and in that generics are used very heavily. So let me give you an example of what I actually mean using class types in generics. So for example, if I want to build a function, right, which creates an instance of a class, and that instance is a generic type. So I will just say a generic type T, but inside a parameter, I actually want to take in class as a parameter, right? So if I want to take a class as a parameter, the notation of that is you can define a parameter name such as like class name, right? And then I can define it as this. So I will just do new, and it will return type T, right? And that's it. So what this says is that we are basically defining a we are taking a parameter, right, which is of this method. So this new bracket, it is basically saying that it is a constructor function, right? So now what I will do is I will just say return new class name, and that's it. So what is basically the use of it? So for example, you have a class as car, right? And car has like number of wheels as a property, right? And you have another class which is like Honda, and this Honda car extends the car object, right? And it has, I don't know, like some other property like is manual, something like that, right? And I have another class, let's say Mercedes, and extends car, and it has a value, can be anything, has heated seats, something like that. So for example, now I want to build an object of these classes, right? So what I can do is I can create a function called create like instance or create object, right, which basically takes in a parameter of type T, right? uh, a type T parameter, which is obviously a generic, and we are taking in C parameter, right? And the type of C parameter will be a class name, right? And which is basically a constructor function. So this is a constructor function, and we are returning, right? So we are returning C new C. So this basically means it like we are whatever the class name we are passing in, we are creating an object of that class name. So right now I can call create object, right? And in that I can pass in a class name such as Honda, right? So it will create an object of Honda, right? and if I pass in a class name as Mercedes, it will create an object of Mercedes. So when you like do a dot annotation trying to access the properties, so is manual is a property of Honda. Now so here is like a perfect factory method, but what if you want to make sure that whatever the class you are passing, it should always be of type car, right? So the easiest, like the best way to do it is like you just say extends car, right? So now when you say extends car, now if you, for example, I define another class, I don't know, have a method called another class which doesn't extends car, and if we try to create an object of this with that method, now we can't because it doesn't extend car. So here you are basically passing in class type. You are passing in a parameter of Honda class, right? A parameter of Mercedes class, parameter of another class, right? And you can pass in by using constructor function. All right, so moving on to my next topic is index signature in TypeScript. So index signature is used widely in TypeScript generics, but this is one of the fundamental concepts. So if you want to learn in a very detailed way how TypeScript generics work, like the most advanced types, I think, in my opinion, index signature is one of the concept which you should be aware of. Okay, so let's start with what is actually index signature. So like just going from the business, going from the basics of index signature. So for example, I have a array, right? And that array is like 1 2 3. So if I want to access the first value of the array, right, I will just go by this index. So I will say, okay, give me the index 0, and at index 0 give me the value of that, right? So that will be 1, so that is fine. But the best part of TypeScript, I mean, you can say in JavaScript, is, so for example, if you have defined an object which has a key value pair, right, a property, let's say A, and it has a value of 1, and a property of B has a value of 2, let's say 3, whatever. And if you want to say, okay, give me the value of property A, so you will go like object of property A, right? And if you do that, you will get the value 1 right over here. So this is one of the ways in which the indexing thing works. So you are basically accessing the object value by its key, and the key is basically the property, right? And you are accessing that by uh, an index. So an index can be a number or it can be a string, right? So what happens if I do this, right? So if I do this, it basically means like this object doesn't have any property of 0, right? So it doesn't have any property of 0, that's why it says undefined. So this property doesn't exist. Okay, so some of the basics of how this indexing thing is brought up in the generics. So now, so for example, if you want to actually define an object which is of dictionary type, right? So you want to define an object which is a very general object and it has a key and value, right? So let's say I have a type, say foo, and what I want is that the property of this foo should have a value of type string, right? So this is how I define it. So basically what I'm saying is I define a type foo, and it should, and this is what the index signature means. So it means that each and every key in this object should have a value of type string. So what I mean by that is, so for example, I have now a variable of type foo, and that variable is, sorry, just typed it wrong, capital OO, right? Foo. Now if I want to have the object, right, now I can define a with a value of 1, right? I can define b of 2, right? So this is kind of a dictionary value, right? So it is kind of the same thing when in object oriented language you define a map, right? And a map has, remember, in Java we used to say, like, for example, let map, and the map is of type, right? String and string, right? So what that basically means is you have a map and it has a key of type string and have a value of type string, right? So you basically defined that in as a type. And the other best part of index signature is you can also define what the value type should be, right? You can restrict that, as same as how you can restrict that in this map. You can define, like, okay, in a map I can have a key of type string, but I can have a value of type like some object which is like a messages, and it has a value of type string. You can define a map like that. So in the same way you can have a type foo, and you can just, I'll just basically copy this, and you can say, okay, so each and every key of this foo should have a value of type this, right? So now what I have to do is, in order to make TypeScript happy, I have to do this, right? So this can be useful in many ways. Maybe you can have an interface which is map, right? You can have a map, right? Generic map interface, which is basically saying you, okay, hey, this, if this is the generic map type, you will have key value of this and this, right? So that's how the index signature works in defining the types. So usually it is used where you want to define objects which are used as dictionaries, right? So you can have a type which is dictionary, right? And the dictionary, you can just say that it has an index string and it has a value of string, right? So you can do that. So here you defined a type which is dictionary, and that dictionary will be, now by definition of index signature, it will have a key value pair, right, of string and string. Now the other thing to note in this thing is, so for example, if you have this foo generic map, right? So you can, like, you can also do like foo of 0, right? And you can have a value again in this, another value, right? So if I just print this thing in console, like value of foo over here, now you will see whatever I said okay on 0 index, right? Just have a value of this. So it took 0 and converted that into as a like string key, right? So here you can like dynamically write some other values in this foo, in this generic map type which I have defined by index signature. So again, a very useful thing in generics. So moving like in future videos, I will tell you how these index signatures are used in other types or in generics, like other advanced types in generics and TypeScript. Thanks for watching, guys. If you like this video, please don't forget to click on the like button. If you don't like this video, please mention why in the comment down below. Like, share and subscribe. Keep learning.